Welcome to Pointers in C. Today we'll be talking about how pointers work in C programming, and we'll just be talking about the basics of pointers, how they're stored, how they work, what they represent. We won't be talking about arrays or pointer math in this particular video. I have a file that I have pre-made called factpointers.c, and this just contains some code that uses pointers internally, and we'll be analyzing this code to understand how this works. So before we do anything else, let me just compile this program, pointers and fact pointers.c. It's pointer.c, and then let me run fact pointers, and you can see that we have a value, and then we do 4 factorial times 5 factorial is 2880. Let us just check that. Let me open my calculator. So 4 factorial times 5 factorial, that is 2880. So okay, we know our program works properly. We know we can see the code of the program. Now all that's left is to figure out why this works and how this works. Okay, the best way to figure this out is I'm going to pull this onto a drawing pad, and I'm going to explain line by line. So as usual, our program starts executing in the main function, right? So this is the first line of code that's executed. Now here we are declaring a variable x, right? This part declares a variable x. I will zoom in a little bit. Okay, so this part declares a variable x, and then it assigns the value 4 to it. So here what happens is, in this is your memory, right? In memory you have values that are stored at addresses, and each of the cells in memory have a particular address associated with them, right? So this is an address, this is address 0, this is address 1. That's just it's like in an array you have indexes. Even memory has an index or a number that's associated to it to figure out where exactly in memory, right? So when you run this, when this line of code runs, it comes to the bottom, adds x, right? Adds the value x, and then stores the value 5. Now internally it's not going to store this label x. Like the compiler or like your computer doesn't need to know that it's called x. It just needs to know the value of it. But let's just keep it here so that we can understand what's going on. But just remember that only the 5 is going to be saved and not the x. Okay. Once we do that, then this line executes, right? Y equals to 5. So we'll get y, and oh my bad, x is 4. X is equal to 4. Okay. Y equals to 5. These two are in memory, right? And they have these values. Again, let me remind you, this is not stored, only this is stored. This is just makes it easier for us to understand. Now, int fx and int fy. Since these are only declarations and not assignment, they'll only be added to the stack like this. So we'll have f of x, f underscore x and f underscore y. These variables will have space reserved for them, but they'll be empty for them at the moment. Okay. Now, here's the fun part. Here, we are calling the function fact, and then we are passing as parameters the value x and %, this % right here, that's really important, and f of x. Now, what this % represents is basically saying, give me the address of f of x. So if I do this, this is address. Okay, so that gives me the address of f of x. So instead, like here, x, this is just going to copy the value 4, right? Since x is 4, it's just going to pass 4 into x, into num, right? So at when the function starts, num is going to equal 4, because that's what was passed in as x. But here the value of result, the variable result, the value of that result is going to be the address of x. So in this case 8. So this will be 8. And this star represents that this isn't an integer. It's a pointer, right? It stores the address to an integer, right? That's why it's called an integer pointer. So this result stores the address of an integer. In our case, it stores the address of f of x. So there'll be some extra stuff here in between that's related to the function, and then you'll have num, right? Parameters are put in reverse order, so result ESULT, and that will store the value 8 from here, right? That's the address of f of x, and that 8 is just basically a pointer. So if I take this is just a pointer to this value here. So all that's storing is just a reference, right? Like a way to identify where this guy is stored. Okay. Now we pass in these two values. Num is 4, result is 8. Now star result, what this means is access the value at the address of. So in this case, if I do star result equals to 1, what it's saying is go to this address, whatever this is. So go to the value, go to the address 8, and then set the contents to 1. So we follow this, like if I take my highlighter, we follow this pointer. That's why we have that star. We follow this pointer, we go here, and then we set the value to 1. In here we come in and we set this to 1. That's the point of a pointer, is you're marking a certain variable with it, right? This is a pointer to a particular variable or a particular block of memory, to be more precise. Now once that's done, we can come back here and we can see, okay, for I in this, result star equals to I. So here, this again, it says go to this location and then multiply the value in that location with I. So we start at 2 and we go till num. So first I takes the value 2, I equals to 2, it's not less than equal to num. So we come here, we multiply this by 2. So 1 times 2 becomes 2, right? We're going here again because of this star. This is something called dereferencing, right? Dereferencing. That basically is saying go to the address of, at the address of, right? At the address of. So what I mean by this is whatever is on the right hand side, do that to whatever is stored at that address. So this value is 8, we go to address 8, and then we multiply that the value stored at address 8 with I, so we multiply it by 2, and that's why it became 2. Next iteration, I becomes 3, because I plus plus, right? So I becomes 3, still not less than equal to, it is still less than equal to num. So this, we multiply this by 3, so that becomes 6. It's 2 times 3. Then becomes 4. Yes, it is still less than equal to 4, so I is still less than equal to 4. This becomes 4. We come here, we multiply 6 by 4, which is 24, right? Then the for loop ends. We don't do anything, we just leave the function, right? It returns void, and we come to the next step. Now here you can see that f of x, the value of f of x has changed because of the pointer, right? And similarly, y is using the address of fy, and now num will be 5, and then result is going to be 7, right? That's the address. Now note, these numbers aren't always going to be the same. It could be any number, it's just the address of. It's a pointer, right? And you point to a particular variable or a particular point in memory, right? Similarly, this is going to run through the same process, and then it'll get to 24 times 5, I think that's 120, right? Then once that's done, now f of x and f of y have values, and now it's going to print f of x times f of y, which we figured out to be the given value, which was, if I run this again, 2880. So 24 times 120 is 2880, and that's what is printed here. I hope this makes sense. Only thing I'd like to add is if you wanted to dereference a pointer to use it. So for example, here we're changing result, right? We're setting result to 1, but we can also print result. So we do print f %b value at result. Put this in quotes, then backslash this to get rid of that. Backslash in, and then star result. Okay. Now let me just gcc // flag pointers. Okay. So you can see value at result is 1. Value at result is 1. That's because the way this works is this is saying, don't give me result, give me the value that's at the address of result, right? We're dereferencing it. I can print just result, and since result is a pointer, we use something called, we use %p to print a pointer. So this is value of result, and then we remove the pointer. We remove the star to say don't dereference it. So I'm going to print both value at result, and then I'll do star. So if I do gcc // fact pointers, okay, so that you see that that's some number, right? That's a hexadecimal number, and I can quickly convert that for you. Copy that, paste that here. So this is some enormous number, right? That's just the address. So the value of result, the thing that was passed in, is this number, but the value at result is 1. The value at result is 1. And instead of this, we could have passed in x as well. So let's see what happens if we do that. So if I do and then fact pointers, let's see. Now, let's say instead of f of x and f of y, we get rid of these variables and we pass the address of x and the address of y. And here I print x, y. Okay. Let me change this to be here. Okay. So before I set it to 1, I am printing the value of result and the value at result. Okay. And let's carefully look at this code. We are to the function factorial. We are passing 2 parameters. The first parameter we're passing is x, and that's just going to be 4, right? The next parameter is the address of x. Now, if we quickly go back here, that's going to be a number like this, 10, right? That's the address of x. The value of x is 4, the address of x is 10. So this will just be the address of x, and the computer is going to give it some address, and it's not going to be the same every time. It's going to be different every time you run it, and depending upon the order of the variables. But just know that that's some number. That's where x is stored. At that address, x is stored. And then same here, we pass in y, we pass in the address of y. Okay. When we pass in x and this, those values are copied here. So num becomes x, which was 4, and then result becomes the address of x, which is some number. Okay. In our diagrammatic example, it was 10, right? So result becomes 10. So the value of result, that's going to be the number, some address, and then the value at result, right? Since this x hasn't changed yet, the value at result should print 4 because we gave you the address of x. So if I go to the location of x and I look at what's in that location, that's going to give me 4, right? At location 10, I have the number 4. So let us check. Right, quit. and GCC fact pointers. You can see that's the value of result, and then value at result. You can see that's the same value as x, and then value of result, and then value at result, and then we get the same answer. Now this worked because we are printing the value of result here, that the value 4, before we changed this. So once it reaches this statement, this value is now changed to 1, right? And then the rest of the thing is computed, and the same way factorial is computed. And num, since num already exists, it doesn't affect num. This only affects x. I hope this makes sense. I hope now you have a little better understanding. To summarize the main things you need to know, you declare a pointer by doing int or any variable type, right? And then star, and then the name of your pointer. So px. So this line declares a pointer, an integer pointer. Let me make it more precise. An int pointer px. Then once we do this, what we can do is we can say px equals to and %x. And this, what this does is assign address of x to p of x. So this finds the address of a variable, right? We have a variable, this symbol or this and% finds this operator, to be precise, finds the address of that variable. So we store the address of that variable in this p of x. Now we can access the value at that address by doing this. We can do star or like let's say y plus equals to star p of x. Now what this means is, to the value of y, add whatever is stored at this address. And what was stored at this address? It was x. So it'll add the value of x to y. We can change the value at a particular address in a similar way. We can do star px equals to 10. Now this doesn't change px. It changes the value at the address of px. So we have px represents the address of x. It goes to that address and changes this to 10. So this statement changes x to 10. This statement changes y to 9 because we're adding 4 to 5. This statement makes p of x the address of x. This statement declares a pointer called p of x. These are your fundamental pointer operations. And we can talk about pointer math and how arrays work in some other video. I hope this made sense. Thank you for listening to me. Good night.